Hello and welcome to the Smooth Scaling podcast, where we speak with industry experts to uncover how to design, build, and run resilient and scalable systems. I'm your host, José Quaresma, and today we had a great conversation with Maria Petrova, VP of Products at TWAICE and previously Supermetrics. We discussed her hands-on experience on projects where infrastructure is the product, how infrastructure can have a huge impact in the actual end product, including user experience. If you like this podcast episode, please subscribe and leave a review. It really helps the podcast. Enjoy. Hi, Maria. Welcome to the podcast.
Hello.
So I would like to start straight on and talking about this concept of infrastructure being the product. When you talk about that, can you tell us a little bit what does that mean to you? And also, if you can add some concrete examples there, that would be great.
Yeah. So infrastructure is a product, and we know that there are like big companies selling infrastructure as a product. Let's say AWS or GCP and all these offerings around how you can buy infrastructure, some infrastructure components as a service. And that's one story. But what I want to talk about today a bit more is how infrastructure and infrastructure-related decisions when it comes to system design, when it comes to tools that you select, actually affect the product, even if it's not a core product of the company. Even company focuses on something else, like let's say data products, analytic products, or whatever user experience they build, how infrastructure is actually essential to power the right user journey, and how it sometimes gets overlooked, because usually when it comes to infrastructure, all these teams that are in charge of it, like DevOps, they're usually very, very far away from people who make decisions on user experience and product look and feel and how the product will be exposed towards users. These teams never speak. And sometimes it's okay, but sometimes it might lead to some suboptimal experiences and some learnings. So let's talk more about it today.
I like that concept. So that kind of maybe unwillingly, then you're saying that the DevOps engineers might end up being UX designers in a way, right? So that the work that they do has that impact.
Yeah. And they sometimes do not even consider that something that they work on and they make decisions about, like, let's say, which database we will use and the performance of this database can actually affect how the users will work with and perform their working tasks, and how the users will work with the tools that you provide. And yeah.
Do you have any concrete examples that you can share on that? That would be, I think, a really good starting point.
Yeah, so just to maybe come to the products where this effect of infrastructure and DevOps and the way you scale is actually very noticeable. That is usually when it comes to the products that rely on huge amounts of data or huge amounts of usage per second, per minute, like requests per second and things like that. And one specific example would be, for example, if you run some big chunk of calculations for the user, the way you orchestrate this calculation, is it one big job that runs every day, or is it a number of separate, smaller, targeted jobs that are executed on a certain schedule, might affect the user experience in the end of the day. There is a user somewhere sitting, waiting for the results of these calculations. And let's say you schedule the whole thing in a specific time zone. And usually when it's default, it's UTC, right? So something gets calculated, let's say at 1 a.m. UTC, but that means that in Australian time zone, that would be a totally different time. And the user might wait for the data that they need, and it's essential for their work, and they might only get it in the end of the working day. So that's just a very specific example how this architecture decision on how do we orchestrate the calculations for our tool might affect the end user. And sometimes it's like when you base it on the principle, let's say you want to optimize the amount of hours your team puts into that. And sometimes it might be very, very attractive idea that let's put everything into one big chunk of things, because then it's easier to maintain rather than have like 5 different scheduled jobs or spread across some time. But then on the other hand, what it results in that somewhere some person needs to talk to a very unhappy customer because they don't perceive the data that your application provides as fresh and timely.
I see that when you were sharing that example, it did remind me of the batch jobs in the mainframe that is usually running overnight and also having that impact. But of course, now with the time zones, that gets even more interesting, right? Because yeah, as you said, if you're working in Australia, you might have to wait maybe for at the lunch times for those to run or until the end of the day. So that's a big impact on the user experience. It's a good point.
Yeah, and usually when it comes to the applications which are not that, let's say, compute heavy, right, we tend to forget that actually how we execute some performance related aspects of the system might affect the whole user experience and how users interact with the tool. Another example would be the performance of your database. For most of the solutions, the databases provide good enough performance that nobody even notices there is some sort of like slowness, a problem with the response rate, or something like that. But again, like when it comes to the higher level of calculations needed to provide the response for the end user, you might end up in trouble as somebody who develops a product. And I think now, as we are moving into this whole AI era and compute all of a sudden starts to matter, it's so funny how I was at school and we had all these like desktop computers at that point in time with where you could accelerate the calculation speed if you want to run a video game. And then like maybe for 20 years, nobody cared about compute, how performant is the system that I work with. And nowadays it's all of a sudden becomes very essential again, because all these AI powered applications, especially large linguistic models and everything on top of that, actually requires a lot of compute, and performance matters all of a sudden again and again.
Maybe some kind of trying to get a few more examples that I think it's always interesting to hear from those. I understand that at TWAICE, was there any kind of specific infrastructure change or decision that you experience kind of bringing noticeable changes to the product itself?
Yeah, for sure. So maybe we should explain to the audience what TWAICE as a product is all about. So TWAICE is the product that I've been working on for the last 2 years, and it's a very interesting system. It helps to navigate through performance of big energy storage systems, BSS, and this is a new way for people to get energy, right? We now use more and more of these like green sources of energy, and one of the ways to do it is to power all these big energy and grid systems with storages, battery storages. When energy is not that expensive, you can accumulate a little bit more into the batteries, and then when it's time to consume, those battery storages power the grid. And the issue is that this is relatively new equipment that people use for that. This equipment requires a lot of monitoring, a lot of tuning, and for that you need some sort of analytic solution that actually guides this whole maintenance of operation process, and that's what TWAICE does. So if we put it on a very abstract level, there is a lot of sensor data regarding how this plant operates over time. We take this data in, we run some algorithms on top in order to predict if something might go wrong pretty soon or already goes wrong, and point whoever manages this big storage to it. And that means a lot of data. Like every second, some sensor tracks some essential information like voltage, like temperature, all the things that matters to evaluate the performance of the storage. And for us, it's always a journey to find the balance between number of signals we take in and the quality of information we provide back to the customer. Because sky is the limit in terms of data resolution, sky is the limit in terms of the volumes of the things that you track, but then there is a huge cost factor attached to it. And in that sense, we've been on a journey to figure out how to balance what would be the right resolution where we can still give a good calculation, a good prediction that customer can trust and actually guide the decision making with, versus the number of signals we use And this is the dilemma that we are constantly fighting. And of course, like when we started, we were very open to accumulate as much data as possible and trying to process it as fast as possible. But then we had to develop some algorithms where we're a little bit more smarter in terms of what resolution actually makes sense, where additional data creates rather noise than provides clarity, and making all these trade-offs on the go. And as I said, it's a journey because we learn all the time, like, all right, those sensors are actually something that is very essential for us, and we need to use it with a certain data resolution and a certain data structure. And there are some sensors that we can probably not consume data from that frequently.
The algorithm that TWAICE is using and working on, is it mostly around the maintenance, or is there some component of the distribution of energy as well, and where it should be kind of saved? And sorry if it's a very stupid question.
No. It's not a stupid question. We do not touch this kind of like energy distribution at this point in time. It's just not in the scope of our solution. We focus on a different story. We try to understand how equipment works in order to ensure that equipment performs according to what was promised to the customer, right? Like this hardware, I don't know if some of the listeners or you yourself own an electric vehicle, you know that there is a battery in place.
Yes.
And this battery on the screen tells you like, okay, with current state of charge, you can drive for that many kilometers, right? But then depending on how long you've been using this electric vehicle, you might notice that you can drive less and less kilometers with the exact same state of charge. Or you can find yourself in a situation when it gets colder, as it does in Nordics where we all live. You also have a problem with the battery performance. So what we try to do, we try to understand which factors affect that and give a heads up to the customer, like saying like, okay, you might run into problems. You need to fix something. You need to tune something, plug some stuff in and out, connect a disconnected equipment module, all things like that.
That makes sense, and I definitely experienced that on my electric car, and now with the winter coming, and yeah, that's always an interesting problem.
Yeah, and ideally we are maybe as humanity in 10 years from now we will get to the state where batteries are more stable, because we of course want everyone to use more green energy. But so far it requires a bit of tuning, and I think analytics is essential on this whole journey of enablement, the green transition in a sense.
But is TWAICE kind of also are you also evaluating kind of car batteries? I mean, I know that batteries, kind of cars themselves, can sometimes be used as kind of this battery in a grid system as well. Are those also part of your system in some cases, or it's more just the power walls of the world and other batteries?
So majority of our customers are currently the small industrial customers who own big storages, but the algorithms that we develop are quite agnostic, so they could be applied to the end user consumer solutions as well. It's more the question where you want to focus, right, and where you can make more difference with what you have. And for now, we decided to focus more on this like enterprise level storages and enterprise level customers. But the same logic, same algorithm could be applied to regular users as well.
Very interesting. And so when we were talking about the kind of this infrastructure being the product, you explain it from the lens of a DevOps engineer that is making some decisions that might affect the user experience. But if we turn it the other way around, we could look from another perspective, which is the product manager, right? The PM, and I guess that from that side, one could also say that it's important for a PM to grasp some of those concepts on the infrastructure side, right? So is there any kind of top 3, top 5 kind of architecture choices that you think a PM should grasp?
Yes, for sure. And there is always a debate. If you go on LinkedIn, there are multiple posts debating how technical product managers should be. And even if we go one step further, how technical product designers should be. And of course, it really depends on the product that you're dealing with. But I think it doesn't hurt if you keep in mind that some of the technical concepts and the decision making on that side, on the system design side, might affect how your product perceived by the user in the end of the day. So I would say there are a number of things that product managers need to know about so they can ask the right question at the right time when decision is made, right? So for example, and also the questions and also maybe the information that they need to bring to the table to empower the right decision making within the technical team. So the questions would be around, do you guys believe that with decision you're making, we can support that user experience? And ideally, at that point in time, you open up some sort of tool, being it a mirror board, being it a Figma prototype, explaining like, hey, there is a user and he expects, for example, to receive certain notification or certain report at that point in time. So basically describing the target picture. That's a really important thing. And then asking a question like, okay, that's my target picture with all the complexity that we have. What needs to be in place to actually power this experience? Do we believe that, just getting back in time, MongoDB can handle the amount of users that I want to introduce towards our tool? Or maybe we should go with something a bit more reliable. Maybe different database will be the better choice for us. Or another, if we move from that part like to probably more like an enterprise solution space, do you people believe that with this choice of tools that we are using to power our system on the DevOps side, we can still be compliant? Because if you're building enterprise solutions, that's a question your customers usually ask. And then there is a lot of open source, newly developed things. They might not be just compliant for the use cases that customers have. So I think first, of course, it's just figuring out if the solution is performant enough to deliver the right customer experience. The other question, if you're dealing with B2B enterprise software, if it is compliant. And then third question, how do we scale, right? We might exist in a situation when we are just pushing something to market and it's a newly developed product and our customer base is free users. So there is no need to scale, right? But if we believe that there is potential there, we probably will invest in marketing. There will be more users. So how do we scale the system? Do we have enough capacity? Have we considered all the different options? The fourth question comes to where we started this conversation, time zones and regions. There are quite a lot of questions nowadays related to where do you store the data? How do you handle the data? And again, if it comes to the kind of these cluster solutions that I call compute heavy, where you perform the calculation might affect the speed of delivery of the end solution towards your customer. So basically, let's talk a bit about regions. Where do we host the solution? Where do we host customer data? How do we run all these queries? Because that also might affect the overall setup that we are delivering. For example, when I was working at Supermetrics, this is another data-powered solution. It's basically data pipeline for a digital advertisement. So solution by nature covers a lot of consumer data, customer data, which has now a lot of laws next to it, like GDPR in Europe, for example, and also lots of regulations on how you can handle it. And whoever needs to handle this data, whoever you empower to handle this data, usually has some opinions on how the data should be handled. Even like the fact where you store it, even the preference for the system where you store it. One of the interesting challenges that we had at Supermetrics was regarding the fact that, for example, if customer is already, and it's a little bit like Apple and Android, if customer is already AWS customer, they of course prefer that whoever is dealing with their data is also AWS system. Or if customer is a GCP customer, they prefer that everything stays within GCP and Azure, and I can name more solutions like that. So how do you go about this approach? How can it become multi-storage, for example, if it's needed? And yeah, it feels like that's a very technical question. And you would probably start to approach it from cost perspective, efficiency perspective, all these things. But at the same time, there is a very important customer perspective that product manager needs to be aware of and actually bring to the table when those decisions are made.
And in Supermetrics, right? I understand that kind of the fact that that is so data heavy, and as you're saying, kind of the difference on the expectations from the customers on which cloud to run and all that, that must have made it quite complex to work on. So do you have any kind of examples or on that discussion and how you went about any of those decisions on kind of in which cloud to run it and how to handle such requirements?
Yeah, so actually we had to do a lot of user research, because also one thing that goes probably beyond product management and any infrastructure related engineering task is a factor of cost and how this whole thing affects the business. And if you look at the cost structure of modern tech company, it is usually so that probably the first line item would be people-related expenses, right? So all the investments that those companies make in talent. And the second line item would be infrastructure-related expenses and all the investments that these companies make into compute and all the related stuff. So there is a lot of things to balance when you think about what would be the right design for your infrastructure. And if I get back to Supermetrics times, without oversharing on some not maybe publicly open details, it was really important to understand how we can empower the best user experience. Because, for example, there is one place where your data is handled, and then there is another space or place where you analyze the data. And majority of the customers, when it comes to data analytics, they use a lot of these publicly available tools, either within Google or Microsoft ecosystem. So to name, I'm not sure if I can name, but I will. It's like Google Sheets, Looker Studio, and Looker Solution powered by Google, or Excel, and Power BI, and all these solutions powered by Microsoft. And then how in the end of the day, we want people to be very empowered and not thinking about like pouring some coffee and waiting for numbers to come into the report, but actually working in these tools and getting insights as fast as they can. So how can we make sure that whatever we need to deliver gets delivered to the end user interface as fast as possible? And then, of course, it was a little bit of us considering a multi-cloud approach and maybe figuring out what would be the best place for this specific user to run their data operations. And it is actually a very interesting task to solve. And I think more and more companies face it for various reasons. One of the reasons to make sure that you design it in a way that is the most convenient for the customer. The other reason is, for example, that there are some compliance things and some customers really prefer one cloud over the other. So I think that I see, at least around me as well, that there are more and more multi-cloud solutions going on.
Yeah, very
and
good.
Of course, like these big companies will be pushing you to get your loyalty straight and stick to one, but you need to think what's the best for your business and what's the best for your user.
Yeah, and I think I guess there's also the geopolitical reality these days that also is just I think exacerbating that need to be kind of a multi-cloud and able to cater for different requirements and different wishes.
Yeah, so maybe for those people who are building enterprise solutions and listen to us, it's also that if, for example, customer handles their data in one cloud and your system runs in the other, there will be unattached cost to moving from customer cloud to whichever solution you run. So again, considering a multi-cloud approach might be more cost efficient in the long run.
I would actually, you mentioned kind of the cost efficient side of things, and you've mentioned kind of compute kind of overall a few times. I would actually like to go back to TWAICE and the work that you're doing there, because I understand that some of the very interesting work that you've been doing was around kind of reducing the cost, right? Because you talked about that there's a lot of data that you're getting from all the sensors, and as I understand, some of the challenge at some point was kind of how can we kind of get the right amount of data to compute, but also at the same time reduce the compute cost that allows us to give the users the right insights to help them, right? So can you tell us a little bit about the key changes that you've done there, looking at the reducing cost?
Yeah, so basically, I think it's a little bit of this story when company starts to operate and scale. Like usually when you're a tech startup, you start with MVP, and what you're trying to build is a proof of concept just to justify, okay, we can solve this pressing problem for the customer, and actually something that we build can produce a meaningful outcome. But then usually if you have enough customers and enough data to work with, there is a question of scale. And it hits you differently depending on the specifics of your solution. And in case of TWAICE, we started by building this intelligence layer, right? By building these algorithms in the first place, and very strongly investing in data science. And if we have some listeners on the call, not saying anything bad about data scientists, but they usually work with these data notebooks. It's either Pandas or Databricks or something like that. And those solutions by nature developed for ad hoc analysis, right? So you get a lot of data, you spend a couple of days, you get your results. And it is not the easiest thing to run the same algorithms over and over and over again in, let's say, like, I wouldn't call it industrial environment, but actually like repetitive and scalable way. So for us, it's been a huge journey to actually figure out how we can optimize all the algorithms without losing the quality, without losing the accuracy, but making sure that they're performant in the new environment, in the new situation where we have quite some customers and quite some data to work with. So basically, like the first thing we've done was just the optimization of the calculation. So basically moving from more like this data science proof of concept approach to actually writing a robust calculation layer which can be applied at scale.
And when doing, were there any notable trade-offs when starting to make that change?
Yeah, so basically it's not even a trade-off for us. Accuracy and making sure that we have the best calculations is a really hard requirement, but then you also want to keep it intact, but at the same time somehow figure out how to do it with less time, with less calculation. So that was something that we were iterating on algorithms quite a lot, moving into that. And I guess like the other trade-off, which is again like not necessarily a trade-off, but some creative challenge for engineers, I would say, how you can decrease sometimes the amount of data, how you can decrease the resolution and still deliver meaningful results. And that again, where I think engineers might partner with user researchers, product managers, product designers, because sometimes it's just the understanding that something needs to be calculated every 5 minutes. And in some cases it doesn't. And that's how you can gain a little bit more of capacity for other things that actually need. I can give you an example from battery world. So getting back to the battery in your car, there is this measurement that actually describes the state of the battery quite well, which is state of health of the battery. So basically, without going into lots of details, state of health tells you how far your battery, how old is your battery. So how far it from the initial nameplate capacity that was in it and someplace at some time when it was just deployed into, for example, your car. This measurement doesn't change every day. So your battery degrades, but it degrades really slowly. If everything is fine, if there was no problems with manufacturing and things like that, nobody needs this calculation every day because it will not change that fast. You probably need to update it weekly, in some cases monthly is enough. And this is when you start to think, okay, how do I orchestrate this whole calculating layer, which takes a lot of energy, like even electricity, right? And a lot of capacity and money to pay for. How can I make sure that these things actually can deliver not that frequently? These things are actually very essential for some operations that happen every hour or maybe every some minutes, and let's put more emphasis, more effort on delivering those in a timely manner. And then let's put something that is not that dependent on the time aside. And that was actually a very good example where we spent some time figuring out the usage patterns, figuring out the user journeys, and based on that, optimize the system itself.
And I guess that's a little bit what shows in the batteries on your mobile, on our mobile phones as well, right? You can also get the state of the health of the battery there. Okay, that's
but again, like if you don't do anything crazy with your phone and battery, it shouldn't change every day. And if it does, then probably take it to some technician to evaluate and a risk of fire or something like that.
And I think before we go into, we always like to wrap up with a couple of rapid fire questions. But before we get to that, is there kind of, do you have a set of rules for kind of when building data as a product? So is there anything that you could share with us? Like what are the main rules for you when doing so?
Oh, very interesting question. And I haven't thought about that maybe like as a rules, but I'm not
it could be guidelines or
I'm more fan of the principles, right? So data, one thing with data, when you build something based on data, is that you can make it as complex, or as some of my colleagues used to say, as clever as you want. And you always need to strive for the balance that you actually deliver clarity first and context and details later. So the principle is how we can make it simple. And this is something that I think teams that work with me, they hate me, but I constantly bring to the table. Can we make it more simple? So that would be the first thing that I would always check. And it goes over everything. The user experience, how people see some screens, how they interact with them needs to be simple and straightforward. But also the more simple and straightforward is the system that powers it, the easier it's to maintain, the easier it's to ship changes. So simplify as much as you can. That would be my advice, and that would be my major guiding principle. And the other one is remember about user and end user experience in terms of regions and time zones. I had even when I was hiring engineers myself some years ago, that was my favorite interview question. Can you please design a simple appointment booking and calendaring app? This is where you have all the possible complexity. And when we talk about data products, their main purpose is usually to inform and provide some insights. Those insights need to be timely. So how you orchestrate all the schedules when something happens, when you pull data in, when you calculate, might affect the end user experience, the decision making, and how much value they derive from the product. So probably these two things are the most important one, but I want to mention third. And the third one is very unusual for, I think, the year 2025. But when it comes to data and analytics products, pictures still speak 1,000 words. And sometimes people go into designing these big tables or writing narratives, but explaining that something is happening with just simple visualization, with just simple picture usually delivers better results and better user experience.
So we go into the rapid fire questions now. I think I only have 3 for you, but and don't overthink them. Just share what comes to mind. Is there any book or podcast or anyone that you follow that you would recommend to our audience?
So I'm very basic on that front, but I would definitely recommend to everyone who is in product or interested in product management to listen to the podcast, which is called Lenny's podcast, delivered from California. So this one I think is a great one. In terms of book, I always, when people ask me, hey, Maria, how do I break into product management? I think that Oldie But Goodie, Melissa Sperry, Bill Trapp is something that every product manager should read. Yeah. And then, I guess there are like multiple sources of information currently. It's like plenty of things are written. I would just maybe give an advice to everyone that when you read it, don't follow it blindly. Try to apply different approaches and see what works for your specific situation. Because there is a lot of this material in the internet which tells you, do this way, otherwise you're doomed. But if I learned something throughout my more than 15 years in tech and product management, that every company is slightly different, every business situation is slightly different. So there is not a ready-made recipe like take that amount of milk and that amount of butter and that amount of flour and you'll get a cookie. You always need to calibrate and figure out what works best for you and your situation.
I love that. That's a great insight. Also because I think often when we see those things about other companies, you're only looking at the end result of potentially years and months of thinking about things, and there's a lot of stuff underneath that, right? And if you only see the top layer and just copy that blindly, then I can definitely see how that can be a recipe for disaster. So it's a wonderful insight. Thank you. And I think you kind of somehow actually answered my next question, but then maybe you can provide a second advice, because the question is, what professional advice would you give to your younger self? So I think we just heard one, but if you have anything else.
Yeah, so when it comes to the professional advice to my younger self, I would say, and I probably want just to share it for everyone who is female in this podcast, don't be afraid to be the only girl in the room, because that was to me a lot, especially in the beginning of my career. And don't be afraid to challenge people with some questions, right? When you're this little product manager who goes in a room full of DevOps engineers, and they're all very serious and not sometimes even taking your challenges seriously, just keep going. They will listen to you. Just make sure that you bring the valuable information to the table.
Thank you. And I'll actually pass that advice on to my 3-year-old daughter. I don't know what she will be doing in 20 years. I don't think anyone has any idea, but I think that advice will definitely still hopefully not with being the only one in the room. Hopefully there will be more, I think the advice will still hold very well. Thank you. Last question. To you, scalability is?
To me, scalability is flexibility. So to be able to scale any system, you need to think a little bit from the get-go on how flexible your system is. It is really hard, especially when you build a greenfield product, something that just starts, to take into account all the potential corner cases, all the potential problems or issues that might arise. But what you can do from the get-go, you can make your system flexible enough to make changes and build on top. And I think that's what powers scalability the best.
I think it's a wonderful way to wrap up the episode with that definition of scalability. It's always wonderful to hear what it means for everyone, since we do focus quite a lot on that here in the podcast. Thank you so much for coming by.
Thank you for inviting me.
And that's it for this episode of the Smooth Scaling Podcast. Thank you so much for listening. If you enjoyed, consider subscribing and perhaps share it with a friend or colleague. If you want to share any thoughts or comments with us, send them to smoothscaling@qit.com. This podcast is researched by Joseph TWAICE, produced by Perseo Mandilo, and brought to you by QIT, your virtual waiting room partner. I'm your host, José Quaresma. Until next time, keep it smooth, keep it scalable.